One more problem from 4.7, section 4.7, number 23. So 4.7, number 23. Find the points on the ellipse 4x to the second plus y to the second equals 4. So find the points on the ellipse that are farthest from the point 1, 0. So find the points that are farthest from point 1, 0. So first of all, if I divide everything, like this is kind of, we learned this in Math 142, we divide everything by 4, so we have x squared over 1 plus y squared over 4 equals to 1. And of course, remember that this is x squared over 1 to the second plus y squared over 2 to the second equals to 1. And so now if I want to graph this, and let me x and y. And so the center of this ellipse is 0, 0. No numbers attached to x and y. X is over 1 to the second, so I go 1 unit to the left, 1 unit to the right. Y squared is over 2 to the second, so 2 units up, 2 units down. Once again, from Math 142, and here is the ellipse that we have right here. And the point that they are actually talking about is right here. It is located on this ellipse, point 1, 0. So the question is that what points are the farthest? It seems from this drawing that one point kind of sort of here and the other point kind of sort of here. Those 2 points have the most distance. So D and D for distance, they have the farthest distance from the point 1, 0. So this point right here, okay? What is the position of this point? Since exactly I don't know, I'm gonna go ahead and call that one x, y, x, y. And I don't need this one for now because this one is up another point, same x values, but negative y values. Okay, let's go to the next page. What do we know about distance formula? We know that d equals to square root of x minus x sub 1 to the second plus y minus y sub 1 to the second. And so one point that we had, remember that we had 2 points. One was x, y, and the other point was 1, 0. Using those points, I'm going to say that d equals to square root of x minus 1 quantity squared plus y minus 0 quantity squared. So d equals to square root of x squared minus 2x plus 1 plus y squared. Okay. And now if I take the derivative of both sides of these, I'm kind of in trouble because I have 2 variables. I have x and I do have y. So what I'm going to do, I'm going to use the fact, the very beginning, that we had 4x squared plus y squared equals to 4, and solve for y squared and say that this follows that y squared equals to 4 minus 4x squared, and replace it, substitute this into my y squared. Okay. So now I'm going to have, let me go to the next page. So I have d equal, distance equals to, okay, square root of x squared minus 2x plus 1 plus 4 minus 4x squared. I can simplify this and say that d equals to, and I'm going to write this, minus 4x squared and x squared gives me negative 3x to the second. Then I have minus 2x plus 5, this to the power of 1/2. So previously we said that in some of the examples that now I can let t equals d squared, and continue with this. But this time, just for the sake of discussion, let's just go from here just to show that it still works. So here I'm going to have d prime equals 1/2 minus 3x to the second minus 2x plus 5 to the negative 1/2 times minus 6x plus 2. And now I'm going to say set d prime equal to 0, because we want to find the critical point. So let's say it equal to 0. Going to the next page, now I have d prime equals to 1/2. Remember that I had negative 1/2 as power. So I have square root of negative 3x squared minus 2x plus 5. Okay. This times minus 6x minus 2. Now I can use zero product property and say that, okay, 1/2 minus 3x squared minus 2x plus 5. This gives me no real solution. The other part, minus 6x minus 2 equals 0, that gives me that 6x equals to negative 2 and x equals to negative 1/3. That's the only critical point that I have, critical point. Now I'm going to test numbers to the left of it and to the right of it. So if here is my negative 1/3, I'm going only to as far as negative 1 to the left and positive 1 to the right, because those are the boundaries for my ellipse. It ends at negative 1 from the left and positive 1 on the right. And if I test values between negative 1 and negative 1/3, I'm going to get positive values in here. I'm going to get negative values in here. So what I have is I have a maximum. I have a maximum in there. So at x equals negative 1/3, we have a maximum. Now, and now I have to find out that, what is the value of y. So remember that we had y squared equals 4 minus 4x to the second. Okay, so I can say that y squared equals to 4 minus 4 times negative 1/3 to the second power. And now, so I have y squared equals to 4 minus 4 times 1/9. and that is y squared equals to 4 minus 4 over 9. And using LCD, y squared equals to least common denominator is 9, so 36 over 4 minus 4, sorry, 36 over 9. 36 over 9 minus 4 over 9, that gives me 32 over 9. And so y equals 6 square root of both sides, plus and minus square root of 32 over 9, and that equals plus and minus square root of 32. I can rewrite that as 4 root 2 over 3. And those are the position of my y's. So what's my final answer? What are those 2 points? One is negative 1/3, negative square root of about 4 root 2, negative 4 root 2 over 3. And the other point is negative 1/3, positive 4 root 2 over 3. So on those 2 points that they are going to be as we predicted, so we have a point about here and a point about here, that the distance is going to be 1, 0, this point here. There are 2 points that they have the most distance from the point 1, 0. Okay, thanks.